Okay, let's just look at our April schedule. Today is April Fool's Day. We're here, we're going to start talking about chapter 12. I don't know why I said 17, 12. And then we have spring break, then we come back, we'll do chapter 12. Lab 5 deadline will be the week after spring break, so if you haven't turned that in, make sure you're working on that. Our last lab will be lab 34, the week following the week we come back. And ALEKS chapter 12 will also be due then. As we're moving forward, think that we only have lab 5 and lab 34 to turn in. So if your lab scores are not very good, make sure you pull it up above 60%. And also be thinking we have chapter 12, chapter 13 tests, and the final. And those all average together to get your average exam score. So make sure on these last 3 tests, you're studying, you're prepared when you take the test, so that when we average your test scores, you can pass the class. You need 65% to pass, okay? Also, the final is worth 15% of your grade, so as we're going towards the final, we only have 2 months left. It's gonna go really fast, so make sure you're finding some time to fit in some final review. We're gonna have 2 days before the final to review in class, but that's probably not gonna be enough, so make sure that you're finding some time outside of class too, okay? Also, this is not on our schedule till May, but keep in mind we also have a signature assignment for this class. So that would be something I would try to get done as soon as I could, so that then it's not interrupting my final study. I know a lot of us also have AP tests to study for, so anything that you can do before those last crazy weeks of before the AP and the concurrent class tests, anything you can do before that is going to help out, okay? So don't forget that signature assignment. All right, questions about our schedule? Okay, we're going to jump into chapter 12. So chapter 12 and chapter 13 are both organic chemistry. Let's see. I don't think I deleted my... Oh, it didn't work yesterday. Okay, got it. All right, so today we're going to try to cover 4 ALEKS topics. We'll get through them. And then you should have some time to work. So we're going to talk about naming normal alkanes. We're going to talk about what that is. We're going to talk about naming branched chains and identifying the parent hydrocarbon of a branched chain alkane. And then we're also going to look at some side chains. So I have a handout somewhere for chapter 12. So I've posted all of the slides for chapter 12, and I posted, and this sheet I think will be helpful. So if you are trying to get ahead on chapter 12, I think with ALEKS, and if you need to look at the slides, you can probably get through most of chapter 12. So we're not going to talk about all of the stuff on here, but most of them today. And then if you want to use this to go ahead, that's fine. All right, so in alkane, we use this word when we're talking about a hydrocarbon chain, and all the hydrocarbon has is single carbon bonds and single carbon hydrogen bonds. That's what we call it, an alkane. This would be considered a straight chain alkane. We don't have any branches, nothing exciting is going on, we just have carbons. Okay, so if you look in this first little table on your handout, if we count the number of carbons, that's how we get the carbon its name. So this carbon chain has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons, and we call this undecane. Okay, this one has come up in ALEKS one time for me, so just kind of keep that in mind. This is kind of a weird one. If it has 12 carbons in the chain, it's called dodecane. Some of the rest of them make more sense. So these first 4, I think, are also unusual. We have methane, ethane, propane, butane. And then if it has 5 carbons, 6, 7, 8, 9, those are pretty common prefixes. So pentane, hexane, heptane, octane, nonane, probably even decane. Those are pretty common. Do you agree with that? You've heard like those prefixes. So those make sense to me. These first 4 don't make sense to me, and so the way I remember them is using a trick. So when I learned these, I learned monkeys, eat, peeled, bananas. And that's how I remember it goes methane, ethane, propane, butane. So if you can come up with, you could use that one, or if you can come up with another way to get these in order in your head, that's always helpful, okay? There will be some naming on the final. I looked, I think on the last few, there is at least one naming. So this might be something that you have to remember. And that would be an easy one to come up with some way to remember it instead of writing it on your note card. Okay. So that's how we give a carbon chain its name, by the number of carbons. All right, so we also need to number carbon chains, and this can be a little bit weird. This is something that I would make sure that I practice in ALEKS, so you can get through the topic, but also go back and review it. So you need to find the longest carbon chain. So here, we could count the carbon chain 2 different ways. We can start over here and we can say 1 carbon, 2, 3, 4, 5, 6. Or we can start 1, 2, 3, 4, 5, 6. And it matters which order you start. We want to start so that the side chain, so we have this methyl group here, we want this side chain to be at the lowest number. So if I start 1, 2, then the methyl group is at 2. If I start over here, the methyl group, we don't get to it until 5. So that's our rule. We want to try to get the side chains at the lowest starting number. Okay, and we'll look at some competing side chains too. All right, so here is a competing one. If we start this way, 1, 2, we have a methyl group at 2. And if we keep going, the other methyl group is at 6. And this, we have 2 carbons, that's called an ethyl group. We've got a 2 carbon chain on this branch. So this third carbon has the ethyl group if we count this way. If we go backwards, so let's do that and see what happens. If we go backwards and we start 1, 2, 3, 4, 5, 6, 7, well, we still have a methyl group at 2. We still have a methyl group at 6, but now this ethyl group is at 5. So if we use the green numbering, the ethyl group is at 3, so we're reducing the number of the branch chain. If we start this way, the ethyl group is at 5. So our side chains have a higher number. We want to go with the green one because our side chains have smaller numbers. Okay. All right, so here are 2 more examples. So this question would say something like, we need to figure out where this methyl group is. What number is this methyl group? So if we count from, so first we need to find the longest carbon chain. So if we count from here, 1, 2, 3, 4, 5, 6, or we could count, let's try another way. 1, oh, that looks like not very different. 3, 4, 5, 6, 7. So we want to start with this side chain. So this is going to be our main carbon chain because we got a longer carbon. Okay, but let's also try another way to number this. We're going to start over here. 1, 2, 3, 4, 5, 6, 7. If we use that green numbering, now we have a methyl group at 2, and we have this other methyl group at 3, and then we have 2 methyl groups at 5. Okay, let's look at what, happens if we go with the red numbering. Let's use the other red. So if we go with the numbering starting from here, 1, 2, 3, then we have 2 ethyl groups at this third carbon. So this numbering wins because we get to a side chain first. Does that make sense? Okay. You guys are quiet. So this is something that it seems like kind of straightforward, but sometimes you get like a competing one. So this is something I would just practice and make sure you're comfortable with that. Okay, how about this one? Do you guys want to try this one? What number would that highlighted methyl group be? We're looking at what number would you call that? Okay, I agree with that. Do you want to walk us through how you got to there?
The longest carbon chain is from the top CH3 to the bottom CH3.
Okay, good.
And then there's 2 CH3s that are closer to the top one.
Perfect.
So then go from that side and this side.
Good. 1, 2, 3, 4, 5, 6, 7, 8. Good. Okay, do you see that? Okay, good. Very good. All right, so the next thing that we need to do is if we can number the carbon chain, then we also just need to name that. So if we go back one, this has the longest carbon chain is 8. So our parent carbon chain would be called octane. So we go to our list. We don't count total carbons, we count the longest chain carbon. So what would this one be called? The longest chain. It's a little bit messy there. Good. So our parent carbon chain would be heptane. So we have heptane with some branches. That's what we're looking for. Okay, and that would be octane with some branches. Okay, so how about these ones? What would this one be called? What would the parent carbon chain be called?
Hexane.
Good, yes, hexane. So we could count this way, 1, 2, 3, 4, 5, 6, and that would be hexane. Good. How about this one?
Butane.
Good, butane. 1, 2, 3, 4. Butane. Good. Okay. All right, so like we've been talking about, I think we're pretty familiar with methyl, and we've seen ethyl. But anytime we have any of these as a branch, we can call that a methyl group or an ethyl group. Or if we have 3 carbons, it's a propyl group. Or if we have a 4-carbon branch, that's called butyl, pentyl, hexyl. Okay, so we're just changing the ending of the prefix. So I think Alex has this table, so Alex must care about these 4. Once you get above 3, we can start connecting. So here we can only connect to 1 carbon. Here it doesn't matter. It's the same if you connect to this carbon or this carbon. It just rotates. It's the same thing. But if we get to 3 or higher, we could connect to this carbon, the end carbon, or we could connect to the center carbon. So that's going to look different depending on if you're connected to the center carbon or an end carbon. So we have to specify what we're talking about. So if we're connected to an end carbon on a carbon chain that has 3 carbons, that's just called propyl, like usual. But if we're connected to the center carbon of a propyl group, we're going to call that isopropyl. Okay, and that's on your sheets too, just in this table here. So watch out for that. That does come up in our homework problems. So let's look at this one. What substituents are present and at what locations? Okay, let's maybe start with what would our parent chain be called?
Octane.
Yep, good. The longest chain is octane. If we count this middle carbon, the longest way we can go is octane. So that's our parent carbon name. Oops. That's an A. Okay, and then which direction would we number? Would we start from the left to the right, or would we go from the right to the left? Good, we would start from here. So this would be our first carbon, 1, and then 2, 2, 3, 4, 5, 6, 7, 8. And that puts this group at position 2. So what would this be called?
Methyl.
Good, we'd have a methyl at position 2. So that's 1. And what is this group? This is propyl. This one is isopropyl because this carbon is bonded to that middle carbon. So we do have to specify this is isopropyl. Okay. Let me just show you if this was, we'll just draw the same thing. 1, 2, 3, 4, 5, 6, 7, 8. If we would have our methyl, if this was just propyl, we would have 1 carbon, 2 carbons, 3 carbons. That would be propyl. This would be octane with a propyl group at 5. Oh. And this is isopropyl. Can you guys see the difference? This one's connected to the, it's not really connected, but it should be connected at that end carbon, and this one's connected to that center carbon. Okay. All right, the last slide is, sometimes this comes up, it's just kind of sprinkled through, so I just thought we should talk about it right now. If you have a question and it asks you to draw something with a chloro group, it just wants you to put a chlorine, okay? The only ones I've seen so far are chlorines, but if you had any halogen, if you had a fluoro or a bromo or an iodo, you just draw one atom connected. So if this one would say something like, draw a chlorine at the second position of 1, 2, 3, 4, 5 of a pentane. It would say, draw a chloro group on the second position of a pentane. Okay? So when it says chloro group, it just wants you to draw a chlorine somewhere. Okay? And when we get to naming, that will come up more. All right. And that's also on, I put that on there because it's also a common substituent that I saw. Okay. Just for fun, what would the longest carbon chain be here?
3.
And what would we call it?
Propane.
Yep, this one would be propane. Good. Okay. All right, we have a lot of time, so what I would do is I would try to do at least these 4 topics in ALEKS that we've talked about. If you have a knowledge check, I'd probably try to get through that. Last time I looked, our average pi progress was at 73%. By the time we're done with chapter 13, you should be able to get through all of it. So you guys should be getting pretty close to 80 or 90% pi progress. Also think about, we have lots of time, maybe if you haven't done your lab 5, get that done. If you think that reviewing for the final would be a good use of your time, you could do that. We have that signature assignment. You could also work on the pre-lab for lab 34. Okay, so we've got lots of things to work on. And we also have lots of time.